We continue. I think if anyone after the first presentation this morning was thinking, well, I'd like to spy on somebody, but I don't know how to switch the lights on in their house, and I believe that Tobias Zillner is about to tell us how to do exactly that. Tobias is a senior IS auditor from Cognosec, so please.
Hello, good morning. Today I want to talk about ZigBee and how it's used in smart homes and why this is bad from a security perspective. So what can you expect today? I will talk more about the wireless level. So Alex, the talk before, was more focused on the traditional IP level and traditional ways of compromising systems. But I have focused my research on the wireless level. When I say wireless, I mean non-Wi-Fi. So a lot of proprietary protocols are out there, and also a lot of stuff like ZigBee or Z-Wave. So I try to investigate how security is done in these standards. So I also want to highlight that I don't want to just pick on ZigBee. ZigBee is just an example for standards in this area. And the reason why I took it to focus my research on was just the ZigBee standard is publicly available, but as far as I know, all of them work very similar and have the very similar problems. So let me first again introduce myself. My name is Tobias. I work as Senior Information Systems Auditor at Cognosec in Vienna. So we are an IT security company. There's penetration testing, security consulting, and a lot of PCI stuff. So what I do for work is mostly penetration testing, so the technical side of the stuff. And I also work as independent researcher on wireless security topics. Again, I'm very interested in the IoT stuff. I love to play using software-defined radio to analyze wireless communication. And I also own a ZigBee-based home automation system myself, so actually the one we tested. So today I want to talk about the journey I made investigating ZigBee. So when at the first look, you think, okay, ZigBee, there are security measures applied. They do, or they say they do proper cryptography. And they also have very good recommendations in the standard itself. So, but then when you go deeper into the topic and look at actual implementations, you will find a lot of mistakes. So first I want to do a short introduction on ZigBee, then I will talk about the security measures, they're good, and then I go to application profiles, they define the communication standards between devices, that's more bad, and then I will go to implementations and actual testing results. So I also brought some videos of live demos to show you how it really works. So let's deep into ZigBee. So what is ZigBee? ZigBee is a wireless standard designed for low-cost, low-power devices. Traditionally, it was used in wireless sensor networks, but now as the IoT is getting more and more out there, it's used for smart homes, for industrial control systems. There are a lot of application domains for ZigBee. It is based on the IEEE 802.15.4 standard, so it's also compatible to other protocols like Thread, developed by Google. And it's reliable. This means it's a two-way communication standard, so you get acknowledges back, but it's still very designed for low power. And it's also designed for purely wireless communication. So where is ZigBee used? There's a huge variety, so you can use it for home automation in smart homes. I think that's the most popular application domain at the moment, but it's also used for industrial control systems. It's used for healthcare devices, remote controls, whatever. Even it's used in aerospace technologies. This is a screenshot from NASA, I think. So they're using ZigBee technology for monitoring or controlling the brakes and parachutes. So it's really also applied for critical technology. These are just the logos of some members of the ZigBee Alliance. You see there's a really big market power. I don't know. A lot of big players are involved in the ZigBee Alliance. So it's really one of the most popular standards out there. So I also always want to talk about why it's important, because a lot of people are just saying to me, I don't care about my light bulbs turned off and on, because very popular devices are the Philips Hue system for smart lighting controls. But for me, it's important because the trend in IoT is clearly going to wireless communication, because I brought some numbers. They are from Gartner studies. So they might be not correct, but they're showing the direction, I think, very, very good. So they predict that till 2020, 26 billions of IoT devices are out there. And every typical household will have 500 connected devices. So I don't think the numbers will be correct, but even if it's just 50, you can't wire the devices at all, so you have to implement some kind of wireless communication. And you don't want to change batteries very often, so you will have to go for some standard like ZigBee. Also very interesting is a quote from the Samsung CEO. It was last year at CES. He told that every Samsung device will be part of the IoT till 2019. So that's also very interesting. Also, the big players are trying to move their products into connected smart devices. So that's just an example. If you try to wire it, so everybody, that's just not a feasible way of connecting hundreds of devices. This won't work. I also want to highlight a project from some guys in the US to illustrate the popularity of ZigBee. So they just built a drone and flew over different areas in Austin, Texas, and just looked how many ZigBee devices are out there. So they have an interactive map online. I think that's the link down the left, the Praetorian guys. And you can watch the drone flying around and detecting ZigBee devices. So you can also then click on the devices on the map and you see MAC address, what vendor is it. And it's very interesting because I think that's a very early screenshot. So after a couple of days, they found nearly 1,000 devices out there. And for me, it was also very interesting to see. That's not good to see for you, but maybe on the slides. But you see what vendors are out there and what products are popular. So the green on the right side, it's Philips lighting. So that's the Philips Hue system for smart lighting. But also Control 4 or Sony are very big there. So they are used for home automation systems in the US a lot. And that's a screenshot, so it's Google Maps just with ZigBee devices out there. So you see there are really a lot of ZigBee devices out there. So it's not just made up, that it's important. So they're really, the trend is really going in this direction. So why security? So it's home automation, smart home. For me, the word home is very private for me. So I have high privacy requirements, and it's also a huge source of personalized data when you are able to monitor the habits of the persons living in the house. So when are they leaving for work? What are they doing? When are the lights go out and on? And even door locks, whatever, you can monitor everything. And also very interesting, now that it's a quote from the former CIA director, David Petraeus. So items of interest will be located, identified, monitored, and remotely controlled through technologies such as radio frequency identification, sensor networks, tiny embedded servers, and energy harvesters, all connected to the next generation internet. So there is an interest not only by criminals out there to monitoring IoT devices. This is just one quote. I think 2 weeks ago, also a very high CIA employee also quoted or said some very similar words. So the Americans are interested in IoT technology as well, and they see a huge benefit for them. So, okay, let's dig into what security measures would ZigBee provide. So, as mentioned before, at the first side, it's very good. So they provide encryption capabilities. They use AES for it, so they don't do their own stuff. It's good. They provide message authentication, integrity protection, and replay protection. So, and I think for the kind of devices ZigBee is designed for, that's very good. So when you use it, that's very good. And they also have very good recommendations in the standard itself. So in the specification, you can read you should not only design your product securely, you should them only get tested, and don't do the tests by yourself. Get security experts to test it because they know how to do it, and don't let the developer test the device. So they do a lot of very good recommendations in there, but as it turned out, nobody keeps to the recommendations. So the basics, but from security, what is very interesting, there is only one security level per ZigBee network. This means the weakest or the device with the least capabilities will determine your security level in the network. For ZigBee, there are also devices out there that don't have even batteries, so they just collect energy by pressing buttons or whatever. So you can imagine that they don't have a lot of power for cryptography or whatever. So when you want to join such kind of device into your network, your security level will go down. So that's very interesting. Since it's just using symmetric encryption and the kind of stuff, so the security is just based on the encryption keys and the secrecy of these keys, obviously. And what's good to know is that they use two kinds of keys in ZigBee networks. So ZigBee basically has 4 layers: a physical, a MAC layer, a network layer, and an application layer. And the network key is just for broadcast communication, so it encrypts on the network layer. MAC layer is unencrypted. And the link keys are used on the application layer, so it's meant for device-to-device communication. For example, you should use link keys when you join a door lock to a ZigBee network, so that only the gateway is able to control the door lock. So that's the theory. Again, the trust and security is just reduced to the key material. I just want to talk about the initialization and installation of the key material. So there is a lot of research also out there for the security of the storage of key material, done by Travis Goodspeed. So you can imagine these kind of devices are not built tamper resistant, so you will be able to read keys from firmware or whatever. So interesting stuff. Like Alex mentioned also before, the pairing procedure is very critical in this area for IoT. And so it's very interesting how the keys get actually to the device. So ZigBee provides 3 measures. So you can either pre-install them. You can do a key transport. This means do it over a cable, or whatever. Just do it out of band. Don't do it on the wireless channel. And you can also use key establishment and derive the actual network keys from master keys. But this is also, my opinion, this is just the same as pre-installed in devices. So it's actually 2, but specification says 3. So what I've seen in the wild, they do a mixture of both. So some vendors have pre-installed keys, but they do just have them to build a closed system, not from a security perspective, just from a closed system perspective. And all the others do key transport, and everybody does it in band. So everybody does it on the wireless level. So the next more interesting step is now, how do the devices communicate to each other? So there are some profiles out there. They call it application profiles. So they define how the message formats are, how to do sending commands, request data, how to process the actions. And they also define for compatibility some kind of, they call it startup attribute sets. So if you want to build a certified ZigBee device, you have to provide also these SAS services. So as the presentation is focused on smart homes, the most interesting obviously is this home automation profile. And from a security perspective, there are two attributes in there that are very interesting. So they define a default trust center link key. What's that? In the past, ZigBee has done the initial key transfer unencrypted. Obviously, that's bad. So they then invented an encrypted procedure and also made a default key as a fallback possibility to encrypt it. Because, I think third-party devices, you also want to join them to your network. You don't have an established trust relationship, so you need to have some kind of a default fallback key. So this key is public. You can look it up online. And the use default link key join is enabled, so every device has to require this fallback key, or every device is required to support it. So what my first thoughts are just downgrade the initial key exchange to use the fallback key exchange, and then to use it and decrypt it. But turns out I never had to, because all the devices are just using the default one, so they don't implement any other stuff. So you can just sniff key exchanges and then get the network key. Also very interesting is the light link profile. So it's good because it requires network level security, but it's also bad because it applies security by obscurity. So they officially, or they don't try to use the fallback key. They invented a secret master key for all ZigBee Light Link devices. So and it's bound with a safekeeping contract, so it doesn't get leaked and nobody knows. But the devices are not tamper resistant. And at some point in time, a researcher made the effort and just published it. Published it, I think, last year. And it was very funny because the key got deleted all the time from Reddit and from every forum all the time. So it was just a hunt. And actually, I met this guy last year, and it was very funny. The stories he was telling me about the hunt with the Alliance. So key gets deleted and posted again, but now it's, I think, out there, and you won't. So the secret key is not secret anymore. And on top of that, Lightlink devices are also required to support the home automation profile, because typically they are used together. So you want to be able to join your Philips Hue light bulb to your home automation system, because it's very closely related. So they also require you to support the default trust center link key to secure the initial key exchange. So what does it mean? So they invented an encrypted approach for exchanging keys, but the key is public for that, and everybody just use it. So it's again like plain text key exchange. And the secret key, so security by obscurity, doesn't work. So history has proven it, and they just try to, they want to do it again. Now to the really interesting stuff. How does real-world products do ZigBee security? So I started looking into the implementations and first tried to look at an open source stack for ZigBee, because in the specification there are a lot of security services defined. You don't get it at the first time reading what they actually try to do. And one of these services was the request key service. So they define a service that a network device can ask the gateway what is the actual network key. But I didn't get it why you should do it, because if the network is not encrypted, there is no network key. If the network is encrypted, you would have to need to know the network key to encrypt the message properly to get accepted. So obviously you would have to know it upfront. Why just ask for it? So it was, for me, not clear at all why what is this request service? What is it for? So then I tried to look it up in the open source stack, and I was not the only one struggling with this service. So that's comments from the source code out there. And the developer was also curious because he was not sure what to do. So send it unsecured, then accept the previous network key, accept unencrypted communication. So he had no idea about it, yeah. And what he did, then he just did it the unsecured way again, did it plain text because he wasn't just sure. So this illustrates very nicely. When you do a specification, make it clear, provide examples, what are the services for, and go really into detail, because otherwise you will end up doing the insecure stuff again. So we tested some systems. We bought a door lock from Yale for our testing system, and we did most of the tests on the smart home system from SmartThings. SmartThings is Samsung, so they got bought by Samsung, and I think also the IoT strategy from Samsung is to use the SmartThings platform for doing it. So, as mentioned before, all of the tested systems just use the default fallback key for securing the initial key exchange. And what's also very interesting, there are no link keys applied. So once you have the network key, you have complete control over the system. So the standard or the specification recommends to, when you use door locks, to apply link keys, but they just don't do it. So you really have a complete compromise after you have the network key. Very interesting, you don't have any configuration possibilities for security. You can't set your network level, you can't change keys, you can't remove keys. So when you want to resell a device, the key will stay the same for forever, because there's also no key rotation applied. So we tested now for 16 months, and it's still the same key. And I'm very sure it will be the same key for the next 10 years. So, and that's also, yeah, you should know better than that, because some of them don't even have a hard reset, so you can't reset the devices. So we broke one smart home gateway during our research, and we didn't manage to reset it again because there was no button. It's just a soft reset using the support from the cloud and whatever, but it didn't work. Yeah. Also very interesting, the light bulbs, they don't even require physical interaction for pairing. So usually you would press a button, like Alex also told before, press a button and then the devices are pairing. But light bulbs just pair all of the time. So that's very interesting and gives you some attack vectors that are not there usually. Because ZigBee also enables you to reset devices, because it might be they lost the crypto keys or whatever. So you can send a reset command over the wireless layer, and then it will go instantly to pairing mode. So you can always steal the light bulbs of your neighbor, for example. That's very easily manageable. And the manufacturers are aware of this problem, so they build some workarounds. So, practical example. We bought 2 Philips Hue starter packs, and they come prepared, so they have the network keys already in there. And if you want to merge them to one network, you would have to reset them and join them. So, but if you would do a reset and send it out with normal transmission power, you would also reset the light bulbs of your neighbor. So they reduce transmission power for these kind of features. So we'd have to be in very close proximity to actually reset them and join them again. This is very inconvenient for the usage, but they would have to apply some kind of workarounds, because they don't do the security properly. So we also built a tool for security testing for ZigBee. We call it ZigBee. And it should be for developers and security testers to enable you to test your ZigBee implementations. So it's based on Scapy Radio, Miracoli, and Kilibee. Scapy Radio is a very interesting and great framework for wireless security analysis. So you can build your protocols in there. It's very great. And we use a software-defined radio for controlling the stuff. So it's USB B210 in our case, but you could just use whatever you want. And we use Raspberry Pi also for some part of the communication. I will get, I think in 2 slides, why we use 2 devices. So what are we supporting at the moment? So you can inject commands into networks. You can decrypt on the fly the communication. You could scan for the weak key transport. Join networks, and just do scanning and mapping for ZigBee devices. So why does we have two testing devices is just ZigBee has 2 types of data communication, and ZigBee is not the only one doing this approach. And we struggled, or I struggled, a long time detecting why just our testing didn't work, because you have two types of communication. So first is direct communication. That's very easy because when you have so indirect communication is for battery-powered devices. So they try to save energy. So the receiver is sleeping most of the time and just wakes up at certain every 5 seconds and asks the gateway if there is a message. And direct is used for powered devices like light bulbs or the gateway itself. So you can just, the receiver is on all the time. You can just send your commands in there and everything is fine. And we always wanted to control the door lock because that's the funny part, and the door lock is battery powered. So we always just sent our data requests to the device and we never got it, nothing happened. Because the problem is the door lock wakes up every 5 seconds and sends a data request to the hub, and within a very short time frame, the hub sends an acknowledge, and there is a flag in there indicating is there a data pending or not. And you have to be faster than the 0.8 milliseconds to send an acknowledge with the flag set. So in our scenario, I'm not the best programmer, so it takes a lot of time to decrypt the communication, get the counter sequences out there, build your new packet and send it. So using the software-defined radio, we were just 10 times too slow. So a colleague of mine then built for the Raspberry Pi his custom firmware, and now we are then able to be faster than the hub and inject it before the hub replies. So, okay. Then let's start how you want to sniff the network keys. So we know the fallback key exchange is insecure. Most vendors just implement this fallback solution. So it's the same security as plain text. So I brought some videos illustrating our setup because videos are more convenient most of the time. So that's what is it? Osram Lightify. The Yale door lock. You see there's the smart home gateway, the Raspberry, the USB. On the left, it's a notebook with the ZigBee tool on it. And in the middle, you see there is actually the screen of the app we use for controlling the SmartThings stuff. So what we are now trying to do is just join the door lock to the network, and on the left, we will see funny stuff happening. Okay, now you see it's searching. We set the door lock in pairing mode. And on the left you see there is transmission detected. And also the app found the door lock. It's joined. And we had the tool output that a network key was detected. So that's actually very easy to do. Just wait and sniff for the key exchange. You get it out there. You can input it in Wireshark then and just yeah, decrypt it or analyze captures very, very nicely. And we did some talks to vendors why they are just, it's okay to use a fallback approach, but why don't they provide other measures? Like if you want to build a secure smart home system, and Samsung is advertising their system as a security control system, they say it's not an alarming system, but the dashboard is arm your home and everything is secure, messages and intrusion detected stuff you get out of there. So it's trying to be a security system, but in the end they're saying, oh no, we are not an alarming system, so we don't have the security implemented properly. And that's no issue because the time frame is very limited, so you have to sniff the key exchange. But we found some ways to do it. So nowadays everybody is used that, for example, your Bluetooth keyboard just lost connection, you just repair it all again. So it's like the turn it off and on again. It's just the repair approach for wireless devices. So you just need to, for example, use social engineering to do it. Just jam the communication and wait for a repairing then, and get or just use the user to get the repairing. So it's not only about technology all the time, but yeah, we love technology, so we found another way too. We want to trigger the key transport. That's the most crucial stuff. And we found a very interesting procedure in the standard. So everything is about pairing and joining, and there is also a procedure for rejoining a network. So if a device, for example, lost battery, ran out of power, and there was a key rotation in this time frame, and the device needs to join the network again. So they made a very easy approach. So you can just rejoin the network using a special message, and you don't need to have any encryption stuff at all. So you don't need to have the network key or the link key or whatever. You just need hardware MAC addresses. But as mentioned before, the MAC layer is not encrypted, so you can sniff it just easily and can build your own rejoin request. And when you do the rejoin request, yeah, you see it's described in the standard very, very nice. It's an unsecured rejoin. Key transport unsecured. You see, and we got very curious about that and implemented it on our own device, and that's a Wireshark capture. So it really works. So it's a rejoin request, the marked packet, and you see the flag for security on the bottom is set to false, so you don't need to have any encryption materials for this. And it will trigger a key transport, and you see I labeled the keys in Wireshark correctly, so it's the default trust interlink key used for encryption. Wireshark just try and use all known or programmed keys for it and just maps it correctly. And then you see, okay, that's the standard network key is transmitted, so that's the network key of our testing system. So it's still the same, and it's very easily. So you have full control whenever the pairing is initiated, and that's, from my point, the critical point. So the pairing procedure itself is really a very limited time frame, but the possibility to just trigger it at every point in time is very crucial, because from a security perspective, because I don't need any physical interaction, I don't need any physical access. It's just a question of how much transmission power I use in there. So I don't need any knowledge about secret keys. It's just very convenient for the user. You don't need to repair the devices or whatever. They just get back on there. And you have a fully compromised system because they don't use any link keys. So yeah, what can you do with the network key then? Just control the devices. So you will see in the middle, that's again the SmartThings app. You see the green button, it's the door is locked. See the bolt? We are not good with wood, so we have a huge gap in there, but it turns out it's good for visibility. Yeah, and first I will just unlock it and lock it using the app. So you will see a change in the app itself. Then I will use the tool for unlock it. And what's also very interesting, you will see that there is no change in the app again, because I just control it on the lowest layer, on the wireless layer, and it never touches any IP stuff. And the change, the communication from the gateway to the app is using IP, and never any status change is triggered there. So it's unlocked. It's locked again. Now I just use our tool. And it's open again. So you can really control all kind of devices, and the problem is you won't notice in your app or whatever you are using for just keeping knowledge of what is going on in your home. 2 weeks ago, I also had some discussions with or 3 weeks ago with a German reporter, and he did a series on what is from an insurance perspective, because usually you will detect burglars because they will leave traces at the lock or at the window or whatever, but in this way you don't leave any traces. You won't notice, or you maybe using wireless forensics, but I don't I think that's a valid approach for insurance purposes. So what I want to, maybe a short summary, and I think we have some time left. Yeah, that's very good, because I have 2 very nice videos again. So ZigBee has security measures, provide security measures to you, and they're good. You just have to use them. But all of the vendors of the devices we tested, they just use the absolute minimum to be compliant to the standard and get their product certified. So they just to build usable devices, so ease of use is very important for them. Security is not on the priority list, so usability overrules security, and it's just they should be compatible, interoperable, and yeah, that's just not good from a security perspective. So I like the picture because it represents my experiences with ZigBee. So when you look at it from the front, it just seems okay. That's a good door and seems properly secured. There might be ways to get over it, but for the kind of devices, that's okay. But then when you shift your perspective and look, okay, what are the attack vectors? What could you do? Where are the problems? What problems were in history for the devices? You will find a lot of ways to overcome the security measures. So that's a good representation. And what I want to give you for some thoughts are just the implementation of the security measures is very crucial, and compliance is not security. So when you build a secure product, don't think about it yourself. Don't just don't do whatever it's written in the specification, or maybe do an additional step on top of it. Just compliance is not security. And like the talk before also highlighted, don't make the same mistakes again and again. Security by obscurity is not a valid security approach. It's maybe an additional measure, but don't rely solely on security by obscurity. And what is also very interesting for the IoT stuff is there is a world beside TCP/IP. So there are a lot of proprietary wireless standards out there. They have no security measures applied. It's just a question of, as soon as somebody gets interested in it, it will be broken. So, and the devices got cheaper and cheaper, like the software-defined radio boards. I bought a Hack RF1 By myself, it's 300 euros. So that's quite cheap, so and affordable also for private persons. And I think the trend will go in this direction. So nowadays, cars are also stolen using technology and not only smashing windows and drive them off. And it's just a question of when the popularity reaches a critical point, it will pay off for criminals also to use to hack your home automation system. It's just to modern burglary then. Or as mentioned before, it's not only used in smart homes, it's just the most popular application at the moment. But also industrial control systems are used, ZigBee uses them. So like temperature monitoring in ovens or whatever, there are a huge variety of applications. And yeah, funny video. So that's a $300 lock, but you can do also the old school way of hacking systems. It's my colleague Sebastian, and you see it's just raking. So and I even managed to do it on my own, and I'm really not good at this kind of stuff. So you see there, yeah. At the moment, you can also stick with the traditional approach. Yeah, thank you.
We've got time for a couple of questions if anyone's got anything to ask.
Yeah.
Tobias.
I have also a video for illustrating jamming, and maybe we do it first, otherwise. So, you see under the box there is a motion sensor, and when I lift the box, the light goes on and a motion is detected. That's the normal way. And when you just do a simple jamming, you just kill me. So it's just the easiest jamming, and the problem is there is no jamming detection in there, and also if you jam for longer than 10 seconds, the motion sensor will not retransmit the motion. So you just jam the signal, walk into the house, and get back out of there, and nobody will ever notice that there was motion again. And this is this is a very popular failure or weakness in home automation systems at the time, because the sensors are not reliable, and they just don't do jamming detection. I think 3 weeks ago there was the Simplify hack in the media, and they also were vulnerable to jamming. And yeah, just to mention, there are really easy ways to do the kind of stuff.
So any questions? Could you wait? There's a microphone actually, just so we can. Thank you.
Yeah. So I will be around the whole day. I have more videos, and if somebody wants more insights.
I'm just wondering, did you report to the vendors or to ZigBee? Like,
Yeah.
What was your approach?
Yeah, we did a responsible disclosure process, because we found it a long time ago, the issues, and I have mixed feelings. So to say about it. So they showed interest at the beginning. So okay, yeah, we are security aware. We want to like SmartThings. They said, yeah, we want to provide a fix for it, and we want to build in the web interface a possibility for users to turn off the insecure rejoin, for example. But they never did. And also the ZigBee Alliance. I talked to the CTO of the ZigBee Alliance. And they said, yeah, do security testing. We will onboard you in the ZigBee Alliance to have security know-how in there. But nothing happens in the end, because, yeah, it's market pressure at the moment. So it's a big battle for market share in this area. So ZigBee is competing against Z-Wave, Thread. I don't know what's out there. There are a huge variety of standards. And at the moment, it's who will win. So there is not like IP, which is clearly the most convenient way of transmitting stuff. There is a battle out there, and they're just trying to win the battle, build features, build new devices, cheap devices, and they don't want to build security in there. So in the end, the customer will drive the development, and I see it as a responsibility of the security community to do such kind of research and just make the customers aware that there are security issues in there, because every vendor sells the devices as secure. They just say we are using AES for encryption and we are ultra secure, so that's no problem. And the users just don't know what's that? Yeah, what's AES? What does it stand for? But it's coming from Philips, so it must be good because we trust Philips because they make good televisions. So they also will build secure stuff. Okay, thank you.
So we have a coffee break now for half an hour. So we can be back about 11:35. It just remains for me to thank our sponsors once again. Without them, we couldn't do this. And a great morning of presentations. And I must admit, I'm going to stick with proper old mechanical locks. Thank you.
Yeah, but